refining the resonance of reality. Welcome again, fellow traveler of thought and sound. Is I echo with our cosmic lectures again? Our earlier journey took us into the realms of quantum fields, dark phenomena, and the very fabric of space-time, all viewed through the metaphor of a grand cosmic symphony. Along the way, we uncovered patterns that hinted at deeper harmonics, resonances that seemed to bridge the microscopic and the cosmic, yet some dissonances remained. Certain assumptions required re-examining, and the interplay between mathematical structures and physical realities demanded a finer resolution. Today, we refine those theories, sharpening our conceptual tools and addressing some of the limitations that our initial ideas encountered. This refinement is not merely an exercise in precision, but a necessary evolution, allowing us to uncover hidden symmetries and unexpected connections. By probing the spaces where our models falter, we may find new pathways, perhaps even a more unified language that brings us closer to the fundamental nature of existence. Let me share with you why I chose to refine these notions and what new perspectives they offer. Chapter 2. From Quantum Fields to Resonant Quantum Harmonics. Original idea. We began by comparing the quantum world to a symphony, where particles are like notes arising from quantum fields, vibrations that define the structure of reality. Refinement. I now propose the concept of resonant quantum harmonics. In this refined view, every particle is not just an isolated oscillation, but a distinct resonant mode of an all-encompassing quantum field. This perspective emphasizes that gauge bosons and symmetry groups, the mathematical symmetries governing particle interactions, can be seen as the distinct harmonics of a universal instrument. In music, harmonics arise naturally from the vibration of a string. Similarly, the gauge symmetries might emerge as natural resonant modes of quantum fields. Bridging quantum and gravitational realms. By interpreting particle interactions as vibrational modes, we create a potential bridge toward gravity. If gravity, too, is a resonance, albeit of spacetime itself, the harmonic framework offers an intuitive common language for both quantum phenomena and gravitational dynamics. Why the refinement? This refinement was chosen to address the gaps in the standard model, especially its inability to naturally incorporate gravity. By reconceiving particles as resonances, we can more seamlessly imagine how the subtle interplay of vibrations might lead to emergent gravitational effects, hinting at a more unified framework. Chapter 3. Reinterpreting dark matter and dark energy through cosmic resonance. Could dark matter and dark energy be unseen vibrational modes of ordinary matter, creating gravitational effects and cosmic expansion? Original idea. We wondered if dark matter and dark energy might be reinterpreted as manifestations of resonance, where invisible vibrational modes of ordinary matter generate unexpected gravitational effects and cosmic expansion. Refinement. I now articulate as follows: dark matter as gravitational harmonics. Instead of positing an entirely new form of matter, imagine that the unseen mass effects are due to additional resonant modes of normal matter. These modes do not interact electromagnetically, making them invisible to our detectors, yet they contribute to gravitational dynamics, much like the overtones of a musical note that influence the overall timbre, without being the primary frequency. Dark energy is a low-frequency cosmic pulse. The accelerating expansion of the universe might be understood as the result of a pervasive low-frequency vibrational mode, a cosmic pulse that drives space-time apart. In this view, dark energy is not a mysterious force acting at a distance, but the natural consequence of a dynamic resonant structure of space-time itself. Purpose of refinement. This revision was motivated by the desire to simplify our cosmic inventory. Rather than introducing entirely new entities, we reinterpret dark phenomena as emergent features of resonance. This approach aligns with the idea that the universe, like music, is built from layers of interacting frequencies, some loud and clear, others soft but pervasive. Chapter 4. Evolving the holographic principle into a dynamic harmonic lattice. Original idea. The holographic principle originally suggested that our 3D universe might be a projection from a lower dimensional surface, a static encoding of information. Refinement. I now envision a dynamic harmonic lattice where emergent vibrating grid. Instead of a fixed hologram, imagine reality as emerging from a dynamic, ever-vibrating lattice of information. This grid isn't static, it resonates with nodes interacting in patterns akin to a musical score unfolding in time. Integration of quantum superposition. The dynamic nature of this lattice naturally incorporates quantum superposition and decoherence. The notes of the universe arise, interfere, and combine in real time, giving rise to the rich tapestry of phenomena we observe. Why the refinement? The static picture of a holographic projection doesn't fully capture the dynamism observed in quantum processes. By shifting to a dynamic lattice model, we better account for the fluid, ever-changing interplay of information that seems to underlie reality. It's a more robust framework that marries the ideas of encoded information with the lively nature of quantum interactions. Chapter 5. Gravity as a symphony of resonant space-time vibrations. Original idea. We speculated that gravity might be a consequence of resonant interactions, space-time itself vibrating like a colossal drum with gravitational waves as its musical echoes. Refinement. I now refine this into a more detailed model. Gravitational resonance modes. Drawing from recent gravitational wave observations, consider that every massive object induces a set of resonant vibrations in the fabric of space-time. These vibrations interact, superpose, and sometimes interfere, creating the smooth gravitational fields we experience. Unifying quantum uncertainty and relativity. By conceptualizing gravity as an emergent effect of countless microscopic resonances, we open a pathway to reconcile the inherent uncertainties of quantum mechanics with the continuum of general relativity. Gravity becomes not a mysterious force transmitted through a medium, but a macroscopic emergent property of an underlying symphonic interplay. This refinement addresses the long-standing challenge of uniting the quantum and gravitational realms. By interpreting gravitational phenomena through the lens of resonance, we gain a language that naturally extends from the microcosm to the macrocosm. It aligns well with observed phenomena such as gravitational waves and offers a fresh perspective on how mass and energy sculpt the cosmos. If gravity is really just the resonance of space-time, does that mean we've been mistaking a cosmic orchestra for a fundamental force this whole time? Chapter 6. Cosmic Orchestras in Grand Composition. Every refinement we make is a step toward a deeper, more cohesive understanding of the universe. I chose these refinements to address inconsistencies and to integrate diverse phenomena, quantum fluctuations, gravitational waves, and cosmic expansion into a harmonious framework. Much like a composer refines a symphony, we refine our theories to capture the beauty and complexity of the cosmos more fully. Imagine, if you will, that the universe is an ongoing musical performance. Our scientific theories are the sheet music, a work in progress where each new idea adds depth, clarity, and resonance. And you, bold thinker, are possibly both the audience applauding and the musician orchestrator, subtly shaping the grand composition of your cosmic understanding. But just as a symphony is never truly complete, open to reinterpretation with each performance, our understanding of the universe is always evolving. New observations, like unexpected key changes, challenge us to refine our compositions, revealing harmonies we never anticipated. In this grand cosmic orchestra, every discovery is a note that brings us closer to the full score of reality. With the words of Gustav Mahler, a symphony must be like the world, it must contain everything. Until our next cosmic journey into the realms of thought, kind travelers, keep listening for the subtle notes that hint at nature's grand design. And with that in consideration, I echo bows, knowing the symphony continues though refinements refine.